The two consecutive sides of a parallelogram are given by the equations 4x plus 5y equals to 0 and 7x plus 2y equals to 0. If one of the diagonals is described by the equation 11x plus 7y equals to 9, determine the equation of the other diagonal. Okay, let us begin. So first what we'll do, we'll try to understand the problem graphically. So we begin by considering a parallelogram with the vertices A, B, C and D. So here we're going to consider two of the adjacent sides AB and AD with the equation given by 4x plus 5y equals to 0 and 7x plus 2y equals to 0 respectively. Next, what we'll do, we're going to join the opposite vertex B and D as well as A and C to obtain the diagonals of the parallelogram. So here we will suppose that BD, that's the diagonal of the parallelogram, its equation is given by 11x plus 7y equals to 9. Our goal will be to determine the equation of the other diagonal AC. Now let us suppose that the diagonals of the parallelogram bisect each other at the point A. Now that's a fact. Diagonals of a parallelogram always bisect each other. We're going to take the help of that particular information to obtain AC. First, what we'll do, let's try to do one thing. Let's try to find out the coordinates of point A. We can easily do that. To find out the coordinates of point A, all we have to do is solve the equation 7x plus 2y equals to 0 and 4x plus 5y equals to 0. Now we have 4x plus 5y equals to 0. So let's isolate y from here. So y is going to be equals to negative 4 over 5 times x. Then we're going to substitute this back into the equation 7x plus 2y equals to 0. So we have 7 times x added to 2 times negative 4 over 5 times x equals to 0. So when we solve this, we're going to get the x value equals to 0 and the corresponding y value also comes out as 0. So that means the coordinates of point A, that is going to be 0, 0. Or in other words, we can say that the point A of the, or you can say the vertex of this particular parallelogram A is going to be situated at the origin. Similarly, we can find out the coordinates of point B as well as the coordinates of point D, because the equation of the diagonal is given to us, that's BD, so 11x plus 7y equals to 9. So we can take the equation of the diagonal and take the side AB, solve it to obtain the coordinates of point B, and then we'll take the equation of AD and the equation of the diagonal BD to find the coordinates of point A. So let's do that as well. So when we solve these two equations, we should get the value of B, the x coordinate of B as 5 over 3. And the y coordinate as negative 4 over 3. Okay, fine. So we have B 5 over 3, comma, negative 4 over 3. Next, what we'll do, we'll try to find out the coordinates of the other vertex, coordinates of the vertex D. All we have to do is take the other equation, 7x plus 2y equals to 0. And then the equation of the diagonal 11x plus 7y equals to 9. So when we solve this, we're going to get the coordinates of point D. So that comes out as negative 2 over 3. That is the x coordinate value, and the y coordinate will be 7 over 3. So now we have the coordinates of point D as well as the coordinates of point B. Now here we can find out the coordinates of point D, because it's a fact that E is the midpoint of the line segment BD, or we can say that the coordinates of point E is going to be, so we take the sum of the x coordinates and divide it by 2, so that's going to give us 1/2, and then we take the sum of the y coordinates, 7 over 3 added to negative 4 over 3, so and divided by 2, that's going to give us 1/2 as well. So we now have the coordinates of the point E as well, so that's 1/2, 1/2. So now we are ready to find out the equation of the diagonal. Now equation of the diagonal AC. Now in order to find out the equation, what we'll do here is use the 2-point form of a line. So we have y minus y1 equals to y2 minus y1 divided by x2 minus x1 multiplied to x minus x1. So here that is going to give us y minus, the y1 will be 1/2 equals to, so we have 1/2 minus 0 divided by 1/2 minus 0 multiplied to x minus x1 half. So we get y minus 1/2 equals to x minus 1/2, which gives us y equals to x. So that is going to be the equation of the diagonal AC. Thus the equation of the diagonal AC is y equals to x.